Okay, so in today's lesson we're going to be looking at variables. And the easiest way to think about variables is to think of them as containers that you hold something in. But you have to declare what type of thing you're going to be holding. So there's a whole bunch of containers out there and you'll put exactly the same type of thing in each container. So a nice way to think about it is like your Tupperware containers. You've got your sandwich container, and that will only ever hold a sandwich, but it can hold lots of different types of sandwiches. So it might hold a jam sandwich, a Vegemite sandwich, a honey sandwich, whatever type it likes, but it's always going to be a sandwich in that container. It's a little bit like a variable. You might declare an integer or an int, and that's going to be a whole number. It could be any whole number, but it must be a whole number. There are other variables as well, like there are lots of other containers. You've got your drink bottles, which will only ever hold drinks. They might be a variable which is a float, which is another number, which is a long decimal number. Another one might be your soup container variable. That one's just going to hold soup, and it doesn't matter what type of soup's in there. It can hold a whole range, but it's always going to be soup. So if you declare a type of variable, it means it's going to be a container holding that type of object. And you know it's always going to contain that type of object. The exact object may change, but it'll always be that type. So it might be a double, which is a really, really long number. It doesn't matter what that number is, but you know it's going to be that number to that many decimal places. And there are lots of variables out there. You might have your lunchbox variable. Again, that contains lunchbox. That might be a Boolean variable. A Boolean variable just holds either true or false. So in this type of variable, you know that it's always going to contain a true or a false. It might be either, but we know that in this container, this variable, it will only ever hold a true or a false. Like this soup container will only ever hold soup. It could be tomato soup, it could be pumpkin soup. It could be a true, it could be a false, but it's only going to be one of those two. So when we're programming, we declare variables. There are a bunch of variables. There's ints, which just contain integers, whole numbers. So 1, 2, 3, 4, 5. And it could hold any of those numbers, but you know it's only going to be that whole number. You've got your doubles, which are your long decimals. It could be pi to 5 decimal places. That's a double. Or a float, sorry. Your double is your really, really long ones. So that might be pi to multiple decimal places. And that's what variables do. It allows us to say to the computer, hold this space, and I'm going to place in that space an integer. I don't know what that integer is, and it might change depending on our program. But always in this space, we're going to declare an integer. So we might declare an integer and call it age. So we've created this container and we've called it age. And in there, we're going to store an int, somebody's age. That may well change. So it might be that one user puts in their age at 32. We know that in this container is only going to be an integer and it's going to represent somebody's age. Another person, it might be 16. Again, it's still an int. It's an integer and it's contained in this particular variable. So when we're coding, we declare variables and we say this is what it will be throughout the program. We can edit and manipulate those variables, but they'll always stay the same. So we might add 4 years onto somebody's age, but it will still be an integer and it will still be in this container. We also have strings. Strings are a really popular variable and they're used to collect a whole range of things. And the easiest way to think about them is an actual ball of string, a long line of characters all stuck together. So thinking about it that way, you can have a line of numbers, letters. You can have a string which contains both letters, numbers, characters. All of these things are strings. But they're not seen as words or numbers, they're just seen as a list, a whole list of characters. So that's really important to remember when dealing with strings. If you have a string of numbers, you can't add 4 to that string because it's just seen as a representation of that character, not actually the number 24. Another type of variable is an array. This is one where you get a whole lot of variables all linked together. The easiest way to think about an array is those medicine bottles, or medicine containers that hold medicine for each day of the week. So here you've got a container which holds medicine for Sunday, and in there, Monday, Tuesday, Wednesday, Thursday, Friday, etc. It's a container, and we could make this container hold anything, but they're all connected together. In this case, we represent the first one with a Sunday, second one with a Monday, Tuesday. With coding, an array is represented, the first one is actually a 0. So instead of Sunday, Monday, Tuesday, Wednesday, we start, the first one is 0, 1, 2, 3, 4, 5, 6, etc. So if you want to access the first element in your array, you need to access the 0 element. Now you might be asking where you might use something like this. It might be that you want to store all the users that access a login to your particular app or website. So our array is a whole lot of containers all linked together. So we might declare an array called names, and it's the names of all of our users. So the first element in our array, which is element 0, might be Bob, who's our first user. Then we've got Ben, then we've got Jill, Jane, and then Sally. So if we need to work out who was the second user to log in, we access the array names and we access element 1. And we have Ben is our second user to access that. And we can store in each of these containers any variable we like. We just have to declare it and then keep it the same. So if it's names, it's going to be of type string. If it's age, it might be type int. Now another one that's also very useful is the dictionary. And just like a real dictionary, it has a keyword and then an explanation. And we can create our own dictionaries with keywords and then an explanation, where instead of it having the key being 0, 1, 2, 3, 4, we can actually make up our own key names. So it might be adding the letters or postcode even of a suburb. So 7052 might be our key, and then the explanation is Blackmans Bay. Or 7000, the explanation is Hobart, that suburb. So we can create our own keyword as opposed to just being the numbers of our array, and then inside each packet is the explanation. So the postcode 7051 might be, that one is inside this character Kingston. So that's just what we do with adding variables. The easiest way to think about them, remember, is that they're just containers. Those containers, though, are designed for one type of thing. And the computer will always think, when it sees this container declared, that it's going to get a sandwich of some description. If it doesn't get that, that will cause a compile or a crash error. So it's important that when we declare our variables at the start, that we know what they're going to be and we keep them the same all the way through. If we try to change them, it causes a compile error. So variables are containers, and in that container can be any type of that particular variable. So we could have a ham sandwich, a peanut butter sandwich, a jelly sandwich, but they're always going to be sandwiches. If we try to do things to it that it's not expecting, for example, a string, we might even have the characters 24 in there, but it thinks it's a string, so it just thinks it's a character. If we try to add 2 to it, it won't be able to do that calculation because it sees it as a string, not a number. So that's really important to remember when we're declaring our variables right at the start.